Hi class, take a second and read this problem. They're basically talking about the following. So there is a loan and the main function that we could use to model the loan, it's basically given here by A. Give me just a second, let me make it thinner. Okay, and the main question is they want to know, they want to find T or X for any other similar problem when it's going to actually be or reach the 70,000. So in this case, we want to find T under the following conditions. So technically A is equal to the 50,000 and then 1.03 to the T. At this point, what we're looking for is when is this function going to reach the 70,000. So that means that we're replacing A for the 70,000. And this is going to give us the 50,000 on the right times a 1.03 to the T. Now what I'm going to do is I'm going to divide by the 50,000, but then carry it as a fraction. So divide by the 50,000 and divide by the 50,000. And then I'm going to cancel those extra zeros. So those cancel, those cancel, those cancel. And we're left as an exact fraction. The 7/5. This is equal to the 1.03 raised to the T value. And then the next step, in order to cancel the exponential, I'm going to take the log of both sides. So technically the log of the left hand side and also the log of the right hand side. And let me rewrite it. What this allows us to do is to drop the exponential. So you have the log of 7/5. This is equal to the log of 1.03 to the T. And then at this point, we can actually drop the exponent. The property that I'm using pretty much says the following, that a log of r to the x is equal to x log of r. Okay, so let me rewrite it with the log already dropped. Not the log, sorry, the T. So we're looking at the log of the 7/5. This is equal to T times the log of 1.03. And then our last step is going to be to divide by the log of 1.03. Okay, and then let me write it as T is equal to the log of 7/5 divided by the log of 1.03. And please evaluate this on your calculator. Let me tell you what I'm getting. I'm getting that this is approximately 11.38. There is a bunch of decimals. I'll say 31.4, and let me just round it to 11.38, and then we could say that it will take about 11.4 years for the loan to reach the $70,000. So let me write it as a sentence. Approximately 11.4 years for the loan to reach the $70,000. Now, on all of these problems, because the numbers are too large, we could have created an error somewhere over here, as perhaps we cancel the values, or if we carried a decimal. If you evaluated the logs, then you would have carried a decimal, and that could have caused a little bit of error. So in order for us to check it, Desmos doesn't produce a very nice graph because of the 50,000. Technically, it's too large for Desmos, but what I did here is evaluate it so that you could see, well, your function A, evaluating it at the 11.38 and technically all the decimals of the calculator displaying, will give you the 70,000. I do expect that you will solve this type of problem algebraically though. That's actually it for problem 22.